The high performance endorsement is not like a flight review in that there's not a minimum amount of time for the ground portion of the flight portion. The FAA just wants to make sure that the pilot understands the constant speed prop, is able to demonstrate proper use of the constant speed prop, understands the proper use of the throttle prop and mixture controls, and is able to demonstrate proper use of a checklist to determine proper settings, proper power settings, demonstrates proper use of the cow flaps during all phases of the aircraft operation, and manage the increased left turning tendencies and maintain directional control of the aircraft during all phases of flight. Let's talk about the constant speed propeller for just a minute. The blade angle control. Once the pilot selects the RPM settings for the prop governor automatically adjusts the blade angle to maintain the selected RPM. It does this using oil pressure. Take just a moment, pause the video if you need to, and review this diagram and read through each of the bullet points below. So now let's talk for just a minute about the induction system. We are introducing a new throttle control in the middle. So now in the middle control, you've got your prop lever. You've also got a new instrument, the manifold pressure. Up until now, you've only worked with an RPM and throttle, and the throttle affected the RPM. What makes this a little complicated is now your RPM is affected by your prop control, the new lever, and your new instrument, the manifold pressure, is controlled by your throttle. So this will take just a little getting used to, and it's a little different than what you might even would expect. So we'll talk a little bit more about this in just a minute. So now let's talk about the controllable pitch prop, the constant speed prop. This will show you here, this talks about excessive manifold pressure raises a cylinder compression pressure, resulting in high stresses within the engine. Excessive pressure also produces high engine temperatures. A combination of high manifold pressure, which again is controlled by your throttle, and low RPM, which is controlled by your prop, can induce damaging detonation. And in order to avoid these situations, the following sequence should be followed when making power changes. When increasing power, you would first increase the RPM with the prop, and then the manifold pressure with the throttle. So if you think about that, an example is when you're taking the runway and you taxi out on the runway, your prop is going to be full forward. So your RPM you're doing all you can do for your RPM at that point. Then when you're ready to take off, you give it full throttle. That's going to increase the manifold pressure as you depart. Now the next bullet point here says that you should decrease the manifold, when decreasing the power, decrease the manifold pressure first. So what you're going to do there is, when you're climbing out, don't reach over to the prop. Start left to right. Start with the throttle, so that's going to decrease the manifold pressure. So a lot of people use 25-25. So we'll use that for the moment. The green, top of the green in my airplane is a little less than 25-25. But you'll reduce the throttle slowly on departure. After 1,000 feet is what I recommend. So climb out and don't mess with your power settings for the first 1,000 feet. Once you've reached 1,000 feet, start easing back on your throttle to reduce the manifold pressure to 25 inches. Then reach over and just slowly turn your prop control, and that will reduce your RPM down to 25. And that's not going to be a very big change for the RPM. But the important thing to remember is the order to do this in, and that your manifold pressure needs to be less than your RPM. Your RPM never needs to be less than your manifold pressure. So now on to cow flaps. With the horsepower being greater than 200 horsepower, the engine and the entire engine area is going to heat more than with a horsepower that's less. So usually cow flaps are doors that are located on the bottom of the cowling, located either inside or outside, and these doors are operated and closed by the pilot from inside the cockpit. Usually they're manually controlled and are operated with a lever and a knob. Here's a picture of a cow flap lever inside the airplane. All the ones I've seen are positioned about here and look very similar to that. You just normally push the lever to the right a little and then push it all the way down and then let it click to the left where it locks. Here's a picture of the one in my airplane as well. The concept here is that the cow flaps are open when you're taxiing and when you're taking off, climbing up the altitude. When you get to your altitude, then you close the cow flaps while you're en route and when you're landing. After you land, you open the cow flaps back up again. That gives you the most cooling when the engine is the most stressed and the least amount of air flowing through the engine. So you've already studied about left turning tendencies and the reasons for those tendencies. With a high performance aircraft, those tendencies are greater. So you have this thing called rudder control that you probably have not had in an airplane that's less than 200 horsepower. So the rudder control is nice because not only at altitude and in cruise, you can make sure it's trimmed just like you would in your experience with trimming nose up and down, but you can trim the rudder left and right. And it's really nice on takeoff because some people like to adjust the rudder just slightly on departure like you would other trim, so you can work a little, not work as hard with your foot on the rudder pedal on departure quite as strong because the tendency is greater with the high performance airplane. Here's a picture of the manifold pressure gauge in my 182 indicating that the manifold pressure is at about 23 inches, which is top of the green, as you can see. And remember, we control the manifold pressure with the throttle. And here's a picture of my RPM gauge indicating about 2,400 RPM, and that's also just about top of the green where we will operate most of the time. And remember, the RPM is controlled by the prop control. And here they are both together. The manifold pressure is on top of the RPM, kind of let you know what it looks like in the plane. Be over to the right of the yoke. Here are our fuel gauges, and in the middle is the amp gauge. As long as it's showing no discharge, we're okay in this plane. It will not show a charge. As long as there's no discharge, we're good. And under the those gauges is the cylinder head temp and the oil temperature and oil pressure. Make sure those are always in the green. Here's my radio stack, a intercom at the top, then the KX165 number 1 navcom under that, and then under that is the Garmin 420, which is what we use primarily. I use that normally for my comms and most of my navigation, unless it's VOR work or ILS. And you can do that on the 420 as well, but 420 I use primarily for GPS. Probably nothing new for you here. Just wanted to show this to you, let you take a look so you'd be somewhat familiar when we get together to do the high performance endorsement. And here are the 3 controls, starting from left to right: the throttle, the prop, and the mixture. This airplane has a nice HSI. If you've not flown with one of those before, I think you'll like it. And it's slaved to the magnetic compass, so you don't have to continually make sure it's caught up with precession from the magnetic compass. And you'll notice on the airspeed indicator, the outside numbers are miles per hour and the inside are knots. And the suction gauge should indicate about 5¼ inches of mercury. that you'll do in the run-up. Here's a copy of the plastic checklist, the laminated checklist that I keep in the airplane. Take a few minutes, pause the video, and rewatch this if you'd like. But take a few minutes to look at each of these categories so you understand, and it'll save you a little time when we get together, of the different checklists for the different phases of our flight. So take a few minutes and familiarize yourself with this, please. Here's the same checklist, just flipped over, emergency procedures and some other things that I think is worth you taking a few minutes to glance over. So here I've just taken some pictures of my POH out of the plane, and it would be a good idea, like I've said on the other stuff, just to pause the video, rewatch it, and glance through some of the checklist information in here, some of the emergency procedures. This is right out of the POH, so this is more accurate if there's a discrepancy between this and the laminated checklist that I keep in the airplane. So I'm not going to narrate this part of it, but if you would just pause the video as needed and familiarize yourself with some of these components. And if I look through this as we're going through and I see some other things I really want you to pay special attention to, I may mention that, but just take some time to familiarize yourself with the POH. And we may actually do some stalls because I think depending on what you've flown in the past, it may be helpful to understand the way this one feels. It's a heavier aircraft than, say, a 152 or a 172. So we may do some stalls. At the bottom of this page, you will notice it begins the weight and balance section. So take a few minutes and look at this section on weight and balance, and go ahead and put together just scratch out on a scratch pad a rough weight and balance. I'm about 225 pounds. So do a weight and balance, and let's kind of have a feel for that.